Welcome everyone. Another episode of Coding Talks. Myself Vishnaviji. Today in this episode, I will be talking about the vector AI capabilities of Oracle 23 AI database. So, from the name itself, you can understand that the database offers some of the AI related features, especially the way to vectorize a chunk of text and do query operations on behalf of that. So this is important in recent days because during the recent OC Yatra event that I have attended at the Oracle Tech Hub Bangalore, during this keynote time, Sandesh Rao and Mike were highlighting the relevance of AI, and it's relevant that Oracle is investing a lot to integrate the AI capabilities in its whole of the stack, including the different services. So it starts with the database. So they have integrated AI to efficiently store the data and retrieve it using the best algorithms. And also on top of that, there are a list of capabilities that they embed within the database, which is the vector search capability that can help the customers to vectorize a chunk of text so that relevant semantic search based operations can be made on top of that. So this is useful than the traditional search where you compare exactly a string. Now, rather than comparing a text with within a document, you can understand that you can query based on the semantic meaning of that word and you will get the better results. So this type of semantic search you might have already found in most of the Copilot as well as in many of the IDs as well, where you can do a semantic search within the code base. So it will exactly find out the specific area based on the semantic meaning. This is useful also for the e-commerce applications where you can query something and find out the exact semantic meaning based search results rather than the exact text string based comparison. So to achieve this, in the Oracle 23A database, they have integrated the capabilities to vectorize the content from a chunk of text, and also once you store that in the database, you can also query as well. So before that, we move more into the vector search capabilities. Just understand a quick overview about the capabilities of the Oracle 23A database. So this is like a kind of a converged database and a multimodal capabilities database, which includes not just the relational database but also supports document, graph, and vector data types. So Oracle had added a support for all these different forms of databases, like whether if you want to store some documents or graphs or JSON or vector data types, you can all store that in the Oracle database itself. So they had added this support quite long back. So one of the advantage that Oracle mentions about this is that instead of having separate databases or specialized databases for different data types, like a different database like MongoDB or DynamoDB for storing key value or documents, you can simply store everything within the Oracle itself. So this is actually a debatable topic where Oracle is primarily a kind of a relational database, and even though it supports you to store the JSON, graph, or document data, it's kind of a conversion because the underlying store is again a relational itself. But this provides some flexibility where customers want to use the relational database along with other types of data models as well. So uh, this is suitable for certain cases actually. Now coming to uh, the AI capabilities, Oracle, like I mentioned previously, Oracle added support for the vector search and AI capabilities within the Oracle 23 AI database service. So on the database layer, they have added a lot of support for the vector data types and vector search similarity functions, which enable efficient high performance similarity searches. So this is not the string match, this is the semantic similarity searches. Also, they have from the query retrieval area, like on the database side, they have added the machine learning algorithm, or OML in short, that provides in database analytics with the SQL based machine learning, automated feature engineering, and automated model lifecycle management. Also, regarding the maintenance side, they have added a support for regression, clustering, anomaly detection, and forecasting algorithms that help with the database without any data movement. So on top of that, I mean, these are specific to these AI capabilities which we just discussed are specific to the database specific services. So on top of that, on the Oracle GCP Oracle OCI infrastructure, they have added a lot of AI services in specific, like Oracle a generative AI services, where you can use an API to query a particular LLM model and do inference on behalf of that. They have also added the different language AI or pre-built language AI capabilities for text processing, vision AI for image analysis, speech AI for audio processing, and the document AI for content extraction and so on. So some of the capabilities were added to the on the database level. So that is why the database itself is called 23 AI. But on top of that, Oracle OCI platform supports a lot of generative AI services and machine learning services, which you can take advantage of to get the best out of the AI. So now we are looking into the vector search capabilities specific to the database. So we are moving a bit deep into the Oracle 23 AI and the vector search capabilities there, so that once we understand that, we can next see what as a customer we can achieve from this, and when we want to leverage other services from the OCI infrastructure. So the related to the database 23 AI, the native vector data type is supported there. So that means you can, when you define a table, in addition to other fields, you can also define a vector field as well. For example, the image vector, if you want to store something as an image vector or text vector, you can define a vector field as well. And this is the high performance vector indexing as well. So the database also offers comprehensive vector operations. So previously we used to search using exact words or image pixels. Because of the vector search, it supports multi-language searches, queries that combine structured and unstructured data, and integration with AI popular models as well. Some of the functions can generate natural language with the help of LLMs. So inbuilt integrations is also there for some of the functions, so that it can query some of the basic level text generation. It won't be an extensive set of text generation. It's kind of a basic level text generation. So then also you can add RAG support, or agentic retrieval augmented generation. So please note that in the retrieval augmented generation, which is called RAG or RAG, you can achieve retrieval and augmented. You can get the chunks. These you can vectorize a data, a text, and make it as a chunk and vectorize it, and then can store it in the database and you can retrieve it. But for the purpose of generation, you need an LLM support for that. As I can understand, the Oracle 23 AI supports some of the functions which can accept an LLM model. These are the inbuilt models, and then it can connect to that model and get some of the text generation for yourself. But other than that, if you want an extensive text generation, a flexible text generation, you need the support of a LLM, which you can either achieve through the generative AI service within the OCI platform, or if you want to combine with other services like, say, for example, AWS Bedrock, you could do that as well. There is another approach also which is nowadays getting popular, which is the agentic core approach, which where basically you will be doing is like you can use a strands like framework with very minimal code to create agents, and you can deploy that on AWS services like Agent Core, and you can provide inputs from these vector search databases, and then you will get accurate responses from there. Usually in Visual Studio and other IDs, you might have seen semantic like search. So that same can be achieved with the Oracle 23 AI database as well, the exact semantic search. So how you will be doing is that first you will be embedding the chunks as a vector and then store it in the database. Then at the time of retrieval time, you identify the text to search or the semantic model to search, and then again vectorize it and then do a kind of a vector, a nearby function, to exactly find out the closest proximity based on that vector, and you will get the exact semantic based search based terms from there. So please note that this will return a chunks of data from the text from the database, and you can present it in a not a kind of a intuitive way. So if you want a kind of a more user-friendly way, you would need the support of an LLM, so that you can provide these chunks to the LLMs and then it can generate the corresponding text. So that is why in the retrieval augmented generation, for the generation part, you would need the support of a LLM kind of a system, or a similar service like a generative AI service like the AWS Bedrock, or some custom form of agents like the agents which were deployed onto the agent core runtime. So agent core is actually to clarify it, agent core is a new service from AWS where primarily you can generate agents using any of your framework as you like. The advantage is that it provides enterprise level security and scalability, so that you can generate agents and deploy it to the agent core. It offers unlimited flexibility, and also it can connect to a variety of models as well. So Strands is one of the popular agent SDK which you can it's actually developed using Python. It's a Python based framework, and you can, with minimal lines of code, you can generate agents, and most of the functionalities are also inbuilt there. Like you can find out the functions for connecting to the file system, functions you can find to connect to the corresponding models. Everything is there within that framework itself. So with minimum level of code and a prompt, you can connect, and also you can switch the models as well. That's another advantage. You can choose different models as well. So another one service which I want to mention here is the generative AI service in OCI. This is similar to the AWS Bedrock service, where it's basically an API where you can connect your applications to. You can provide the input like a prompt. So the inputs from these database, like the chunks retrieval or whatever data or retrieval augmented based context, all these or your enterprise level context, all these comes as an input to these models, and it can provide based on the output, based on the input that you provide in the prompt, and then you can switch the models as you like. So Bedrock service and this OCA level generative AI services supports a lot of models, and they will be constantly adding models as well. You can choose, have the flexibility to choose a model that you want for your application, and you can also switch back the models on the fly as well, so that offers the maximum flexibility, and the cost is based on the inference that you have on the model. So these are some of the approaches, and there is another one approach also worth discussing, which is the metadata only clone approach. So this is an innovative approach made by the Oracle 23 AI for AI development and testing environments. So during the development and testing stage, the development teams or testing team need access to the data, but at the same time, organization can't expose all the secure data to these teams as well. So of mainly the production data. So that time, what this metadata only clone approach does is like it's create a lightweight database clone that contain the full schema of the original database, their vector indexes and metadata structures, without copying the actual vector data. So this approach dramatically reduces storage requirements and clone creation times. Only a copy of that vector and its schema definition is there within the cloned database. So developers can test the schema changes, index optimizations, and query patterns against the production-like structures, while maintaining data privacy and reducing infrastructure cost. In the OC Yatra event held at Bangalore, another one important tool they were highlighting is like the Oracle Code Assisted tool. This is specifically useful for those who actually work and develop within the Oracle ecosystem. So it's an integrated AI-powered code assistance tools directly within the Oracle Database 23 development environments. So the Oracle Code Assist tool leverages the vector search capabilities to provide intelligent SQL code completion, query optimization suggestions, and best practice recommendations for vector operations. The tool also understands the context of vector data types, similarity functions, and indexing strategies, providing developers with real-time guidance for building efficient AI applications. Not only this, it can also suggest optimal vector index configurations based on the query patterns, recommend appropriate similarity functions for specific use cases, and identify potential performance bottlenecks in the SQL vector queries. So this is one kind of AI-based integration in the Oracle Code Assisted tool, which helps in development and to write efficient SQL queries and to make better applications. But at the same time, Oracle has also integrated this into one of their products, which is called the Autonomous Database. Autonomous Database is a self-healing database which does everything of its own, so that the maintenance will be drastically reduced. It can auto-index, auto-tune, So all this is done based on the concept of the retrieval augmented generation, similarity search, and AI capabilities, and it's all inbuilt within the autonomous database. So one question that came up to the developers who were present at that time during the event is whether this will replace the database professionals or reduce their roles. Actually, um, it's a difficult question to answer at this stage because we don't know how far the AI evolves. But at the same time, on a positive note, it's mentioned like these tools actually help, especially those with even with a lesser experienced person can still have understanding about these complex topics and performance optimizations based on the vast index of the knowledge bases these AI systems have. So in a way it actually helps everyone, but the side effect or impact of these tools, it's actually unknown, and either we have to evolve or it would be difficult to say in that aspect. So that's what it's mentioned during that event. Then next one is like so we have covered some of the aspects of the vector search and all. So previously I had a different session about the episode about the Oracle multi-cloud, and in that episode you might have understood about the multi-cloud offers some of the ways by which you can integrate tightly with the AWS ecosystem. It offers low latency integration and it's suitable for applications which require ultra low latency connections. So a similar way, this vector search can be combined with a lot of other existing AI services as well. So this is like a kind of a trade-off where which systems you want to use. It depends on the organization context. If an organization is heavily invested in Oracle OCI based services, then leveraging services from within the OCI like the generative AI services will be worth to consider. But at the same time, the organization who want to use the services from both of the providers, like either in AWS and or in OCI, then an integration is possible. And when it comes to that integration, traditional mode of integrations like RDS based Oracle and EC2 based Oracle installations were a possibility. And you can, with the combination of the vector search that you stored in the database, you can also combine that with the other AWS specific generative AI related services like a Bedrock, which is a managed service, and also the SageMaker. SageMaker offers custom model training and inference capabilities. It's a bit higher service which where you want to have a deep tuning of the model, you need to go for that SageMaker. So Bedrock and Comprehend offers some of the base level foundational model access through an API. You can do the inferencing and without spending much time on the model training, and you can straight away use the foundation models available within the Bedrock. Then other than generative AI, with the integration, you have also the possibility to connect your database data with the Amazon S3, Amazon Glue, AWS Glue, Amazon EMR that supports big data processing workflows, and also some of the analytic services like Amazon Redshift, QuickSight, and so on. So this QuickSight can build visualization capabilities for AI-powered insights. So that's a possibility. So these are all the things that I plan to discuss in today's episode. This episode, whatever I have discussed, a blog version is also available on my LinkedIn and also on the community builder channel. Please have a check on that. Thanks everyone for tuning into this podcast. Have a great day.